Hi everyone. Good morning, good afternoon, good evening, wherever you are. We are back again with our DevSecCon India chapter meets, and today we have a session around supply chain security. Now, supply chain security is something which is picking up big time and something very, very important, especially if I talk about the recent attacks. It started in getting in discussion from the SolarWinds attack that happened. But think of a situation whether are they new, whether that attack was new or we've seen it for the first time. They have been there, supply chain attacks have been there for a very, very long time. And there are many things associated with it, from supply chain nitty gritties, basics, to supply chain risks, to supply chain vulnerabilities, to attacks. So, today in the session, we would be covering supply chain attacks, how exactly your environment can be vulnerable to these attacks, and what are the basics behind it. And for that, today I have Antara Mane with me. She's going to be talking about what these attacks are. Without further ado, let me bring her in the stream. Hi, Antara. Antara, you're speaking on mute. You're like me. I can't hear you.
Hello, can you hear me now?
Absolutely. We can hear you now.
Okay,
Great.
sorry for that earlier.
Absence happens. Let's share your screen and get started with these attacks.
Sure, yeah, right at it.
So, Antara, while you're starting to share the screen,
Yeah,
just tell us about how exactly you thought that you should talk about supply chain attacks. You've been experiencing it, you've been seeing it, or how's that is?
yeah, right. So, as we know, like we are in information security professionals, right? So we have to be active in all the current vulnerabilities that are going forward, right? So we need to look at the aspects of it, right? So I've been working with a couple of organizations here in India, and I got to know certain things that they were lacking. But obviously, we cannot forget the big strangle that this Log4j has did for I mean the damages that it caused for many of the organizations. So that actually was quite an catching vulnerability, right? So keeping the Log4j activity, right? So there it just kept evolving, and then we had the very very recent and many emerging attack on the solar winds, like the Orion software network got compromised, right? So there and there it kept evolving, and seeing the structure of in every organization, like how when it comes to software building, right? So how the process have been defined, its development areas, the process, and its distribution, right? So there are a couple of things that really got my interest, and I just wanted to work and more on it, and like do a bit of kind of a research on it. And so I've also written a blog on this. It's exactly a part of software supply chain attack. It's called an dependency confusion attack as well. So we're going to cover this in the obviously in our upcoming slide. So let me just good share my screen with you all.
Sure, absolutely.
Okay. So I hope my screen is visible.
Let's see. It's coming up. Yes.
Sure.
Over to you, Antara.
Thank you so much, ma'am. Thank you. So, a bit of a background about myself. So, I've been into this cybersecurity research domain for like past 3+ years, and my interest is to find vulnerabilities in all the possible projects that I get to work of with. And I have my expertise around it, like pretty much good. I also love to share what kind of knowledge that I have gained, and whatever research that I've done, to share it with others as well who are learning into this particular domain, right? So I also love to give this kinds of fun sessions to all the possible areas that I can. I mean, obviously, and thank you, Vandana Verma, for having me and allowing me this opportunity. To take advantage of this opportunity and deliver this session with you all. So if you guys have any technical queries or anything, so I have my LinkedIn and GitHub links mentioned here, so we can connect if you have any queries, or if you want any other uh, questions around it or not. So, well, it seems, as rightly spoken by Ms. Vandana as well, that attackers have found like new ways of delivering the special blend of malware surprises, right? So uh, there has been like recent trends, like, so it was like this malware attack that happened on the colonial pipelines, right? There was this another cyber attack on Microsoft Exchange server. That's the widest used email exchange server, right? And there was this back in 2020 that caught everybody's attention, that was the software supply chain attack that happened on Solar Winds, the Orient networks, right? So let's not forget about how the attackers, try on, finding new ways of exploiting certain vulnerabilities, right? And it may seem that, the sentence. So let's just hope that they don't start offering a home delivery service. I can understand that could be, for some, it could be like more of an like exaggeration, sentence. But the idea was just to, let's not, treat this as like a very like lead interested topic, because this is a concern area for everybody, whoever it is, that is dealing in this domain, particularly also in some sort of the developer teams, who are in the picture of forming a certain software for a certain product for certain company, right? So I just wanted to highlight the focus on that each and every exploit that has been developed and discovered, right? So it has its own importance, and we, being in this domain, being in an information security domain, one must needs to understand the criticality of it and act upon it, right? So our today's topic of discussion is yes, software supply chain attack, right? So we're going to understand about it, why are they becoming more prevalent, right? The types of software supply chain attacks, we're going to also understand the recent examples that whoever what all organizations were affected by this kind of an cyber attack, the best practices every organization can follow to prevent itself from being a victim for such kinds of cyber attacks, right? And we're going to have like a Q&A session for like 10 to 15 minutes at the end of this session. So the key takeaways would be having a deep understanding on this topic, software supply chain attacks, right? How attackers exploit this kind of a cyber attack. How do any organization can manage the third party components and suppliers, right? How to collaboratively share information without sharing excessive sensitive information away between the stakeholders and third party vendors. How to keep yourself updated with all the list of libraries and third party components that you use while developing a product. And of course the best practice is to prevent oneself whenever you're dealing with, even if it's like an if you're a developer, what security practice you could follow. And for other information security, like cyber security analyst or whoever, like researchers, so for them also, like the best practice they could give or advise any team that you're working with who falls into these categories, right? So let's just begin into understanding what are software supply chain attacks, right? So before we even understand this terminology, I just wanted to highlight why it has been named as software supply chain, right? So what do you mean by supply chain? So whenever product is being developed in any organization, right, so that development of that product, it requires like a tons of distribution. It requires lots of softwares, lots of libraries involved, lots of process defined, lots of third party components involvement, because in today's world, right, with the evolving technologies, right, there are many technologies that have come up that makes developers lives easier into building certain thing, right? So they keep in dependencies of their product with some of the other already developed libraries, right? So in a way to say that not every developer in this in any organization or around this world will start to create a product like from the scratch, right? We all know there are certain libraries that already does a certain amount of work which could be useful in the product that you're developing, right? So developer, to make the job easier, to make the production easier, and to ensure that the business timelines and deadlines are met, so we do keep, keep a habit of involving such kinds of libraries, such kinds of third party components into our softwares, right? So using these kinds of, certain components or certain libraries, we are in a way we are like creating a chain that is in a way dependent on one or the other, component, and that helps us build the entire product, right? So it's kind of like a supply chain, right, of the entire list of the components that are used, right? So in this attack, so what is exactly software supply chain attack, right? So in this particular kind of an cyber attack, an attacker, it focuses only on the vulnerable and unpatched third-party libraries used in a product or used in software. Right? It keeps a target to those unpatched libraries or those unpatched third-party components, and then it tries to, exploit those particular unpatched component, right? So that is what is called as in software supply chain attacks, right? So here, instead of, focusing to exploit one particular targeted end user, here the focus is on to uses of the list of unparty third party components that are being used in an software. Because it when it comes to software development, right? So as I said previously also, there are like tons of process defined, there are like tons of listing, distribution, and everything. So sometimes there is a possibility, right, where a developer forgets to keep a track of kind of the, third party libraries that are being used, right? So it ends up using some of the other a certain component that is maybe the developer might have forgotten to check the integrity of it and end up including the same into the product, right? So this is the kind of an area wherein attacker thought of, taking an advantage of and then exploiting it to an extent where it could lead to a drastic damage, or cause a real damage, right? And affect or compromise the security of that particular product, right? So these kinds of an attack, it usually involves like insertion of like some malicious code into a legitimate software components, or other distribution of the same across the, entire end users, right? Which is also used by some other organization or some other dependent users, right? So this attacker can allow to gain access to sensitive information and also disrupt the operation of the affected software, right? So a simple example to explain this is, so we do use of you know we all have like a laptops, right? It could be a Windows, it could be like a Linux version, or it could be like Mac OS version, right? So we all know that we also get in tons of, updates by months, or by, certain time interval of period, right? So we do get updates for certain, say for example, if you're using an office or office 365, right? So we do get updates for all the office 365 products, or we do get a kernel based or windows based upgrades, and it's OS based upgrades, right? So what if one of the, updates servers is compromised, right? So compromised meaning if an attacker is able to get in hold of the, the update that has been passed from the actual servers to our endpoint. So what if there is an insertion of an malware, in these kinds of updates? So imagine the damage that it could cause, right? So it is being served to n number of end users, right? And we all will, end up installing that without having the, authority to cross verify its signature or its integrity, right? So sorry, so this is what software supply chain attack is, right? The like understanding the criticality of it, right? And the compromise it could cause, or the real damage that it could cause once it's exploited successfully, right? So let's move on to the next topic, next slide, understanding why they are becoming more prevalent, right? So we all know that this is an evolving technology world, right? So as I said previously in the previous slide, that developers, they use like a bunch of libraries, third party components, that sometimes they are aware, sometimes they are not aware of what certain libraries are um, a certain component that they are using, right? So increased reliance on these third parties softwares or third party components or libraries without verifying its actual source, because there are multiple sources from which one particular packages or libraries or certain third party component that helps make your development easier could be installed and easily integrated within your current existing software, right? So the increased reliance on these third parties components, right? Not having an appropriate visibility to list of like whenever there is this whenever there is a process initiated for any new software development, right? So usually there's something called as software bill of material, right? SBOM, that basically lists all the components that would be used for building that particular software, right? So lack of visibility on what all components would the product be using, along with the packages, right, along with the list of the libraries that would be will be used, right? So not having an entire visibility on that area is what makes the attack surface a bit of an in an increased posture when it comes to cyber attacks, right? Also lack of appropriate security measures, that is not verifying the integrity of certain packages, certain third party components, right, which leads to a potential of high impact when these unpatched third party components are exploited, right? So overall the complexity and the interconnectivity of the software supply chain, that is combined with the potential for high impact attacks, makes the software supply chain attacks as an attractive target for cyber criminals. And it is most important, like, for for all the organization to prioritize the software supply chain security and take the proactive measures to prevent these kinds of an attacks, right? So let's understand what are the types of software supply chain attacks. So before we talk about what are the types of software supply chain attacks, I just wanted to make you understand like how software supply chain attacks actually works. So there was this article released by Microsoft like an year ago, back in 2021. Um, so it stated more on the techniques for exploiting software supply chain attacks. So it did cover a topic called as a dependency confusion attack, right? Typo squatting, some water holding attack, that's also I'm going to cover. So let's understand the concept of dependency confusion attack. It is very similar to software supply chain attack. So dependency confusion attack is something that a developer because see whenever I mean there are like tons of sources available on the internet to if we want to install certain package, right? Or any other library or any other third party component, right? So it could be like React.js, Node.js packages, or it could be any other like Golang or PHP or Python or anything, right? Pip packages, if you're talking about, right? So there are like tons of sources. It could be like public, it could be like private, right? So there are some organizations that very much like to keep these certain repositories private to themselves, and there are certain public as well, for some no, for some reason, right? And for this dependency confusion attack, so say for example the attacker has identified that so and so packages is being used in so and so so and so product, right? So what an attacker will do, it will try to create a confusion attack, because in a way it's like a supply chain, right? The software, the software product and its core list of uh, libraries used or components used, it has certain dependencies on each other, right? So an attacker would create a public package naming which is very similar to the naming convention of the private repository, right? And it will host on the internet. So say for example, let's take an example of npm. So npm is also a package manager for node.js, right? Platforms, right? Right. So say for example an attacker has created its own package and has uploaded it on npm npm.js public repository, right? So we all know that installing certain packages, whenever we are coding, we especially developers mostly make use of and command line instructions to install certain dependencies and to just make the software up and running. So the developer just types in sudo install or npm install or node.js install, whichever package manager it is using to install that particular package or library. So it will type in that command, right, and it will enter the name of the library that the particular person wish to download, right. And of course you might be having question that if we have the same name available in the private repository, then why it would go and hit the public repository. So we also see that there is something called an code tracks, like the version trackers. The command line do understands this. So it by default downloads the latest version of that particular package or library, or whatever component that you're trying to install. So the public one has the latest version of it available. So it will the package manager will definitely install the latest one that is available in the public repositories, right. So that will end up installing the public repository, which is a malicious packages uploaded by the attacker. And that basically compromises a further area of the cyber attack, right. So here the dependency confusion attack is basically getting confused between the packages, right, not verifying the integrity of it before installing it, and not also cross verifying the source, right. And directly ends up installing the same onto your machine and carrying out with the further development, which leads to further targeted and focused attacks, right. So that is the one kind of a technique. Another technique is like typo squatting. So it is also similar. It is like if there is an target.com, so making it again typo mistake, making it like target, like target.com, right, making it like like just making a typo squatting kind of an errors, right. So that is also sometime in case happens in the private repositories as well, because sometimes we obviously when we type in, so we make a tons of mistakes like double e double r, it does happens. So even if the developers are installing certain packages from a private repository, so if an attacker is able to get in hold of the private repositories, right, so it can upload the malicious package onto maybe target.com, right. And when the developer makes this kind of a typo mistake and also end up installing the malicious package, right, that could also is one of the way to perform this kind of an targeted attacks, right. That is in another one. So malware insertion is like once the developer ends up downloading the malicious package, right. So that is how you have already created a malware in it, and you've already uploaded it on certain repo, and which gets installed by a developer, and then your malware insertion was successful, and then so you can perform like further attack. I mean, the attacker can carry out the further focused attack, right, stealing some sensitive information, or maybe exploiting certain other dependencies related to it, right. Compromised dependencies is like similar to what we just talked about. So the packages or libraries, right, that has dependencies on say for example some other library. For example, if you want to if you wish to install one package, and say for example it had a dependency on some other library called as an egress, right. So if you wish to install one node.js npm package via npm manager, right, and it has an very and it has a dependency on this other library called as an egress, right. So your I mean if the attacker is able to compromise that dependent library, right, so in a way you are still installing the malicious package instead of the legitimate one, right. So leading to this could cause an man in the middle attacks. One can actually intercept like uh, all the all kinds of activities that your product is capable of providing, right. So that could be one like possibility for it, one of the types, right. Another one is watering hole attack. So it's kind of an phishing attacks where say for example if an attacker is targeting to uh, one such organization, right, and say for example it has identified its domain availability, or certain website that does contain certain sensitive information, or let's just take an example of an insurance company, right? Leading to some displaying some contents related to policies or something, and you have identified its subdomain, right? So for example it's attackers.com, right? So let me just spell it like the way, I mean, the attacker is spelled as ATTACKER, right? That's the spelling of an attacker, right? And it is focusing that particular website, right? So phishing would be like purchasing the similar domain with a typo mistake. So if it's an attacker, so maybe adding additional a, or maybe instead of .com it could be .in, .org, purchasing these available domains, right? And then hosting the similar content that the legitimate website owns, right? Displaying the same content, right? So if any user, right, if any user visits the attackers hosted website, right? So it will end up providing information on the attacker's website, that is the domain controlled by an attacker, right? So that is something what is called as an watering hole attacks, right? So it's more like an phishing, it's more like an social engineering kind of an attacks, right? So yeah, I mean that's already covered in the previous thing. Um yeah. So these are the few types of software supply chain attacks that can occur, and that has been also published in Microsoft's recent articles on the prevention of uh, security measures for prevention of software supply chain attacks. So if you could, you could just Google this, and you will easily find Microsoft links to it. So let's move on to our next slide. So that is then recent examples of the organization which were badly affected with this kind of an cyber attack. So the first one is SolarWind. This was happened back in 2020, right, wherein the attackers were able to get a hold of the update server, right? So the affected network was the Orient Network Management, right? That was used to push, pull and update data into its own management software, the Orient network management softwares, right? So the attackers were able to insert a code into its legitimate update of SolarWinds Orient networks, right? And this was distributed across of around 18,000 users, which were using this particular software, right? Included the US defense organization as well, right? So the US defense organization, it was badly affected with this kind of an malicious update that was sent through the Orient network, right? And there was almost 18,000 users and users and orgs which were affected with this kind of an attack. So the attacker was able to compromise the updates, the update server of SolarWinds network management, right? And I mean, since we all know that software, SolarWinds is like so SolarWinds of Orient network is like pretty good network monitoring and inspecting tool. So compromising its updates, uh, and which was obviously sent across multiple users which were using this agent of Orient's network, right? They were affected with this with this particular updates, right? And that led to like further damage, right? Of I mean, the attackers were able to steal a few of were able to actually extract few of sensitive information, like were also able to exfilter the data from certain agency onto their network, which was concerning, right? So this is one of the example, right? Another example of software supply chain attacks is the code co software supply chain attacks, right? So Code Cove is a CLI, CLI bash uploader tool, right, which is basically used to keep a track of the statistics report that is being generated by various programming languages used in an organization to the code code repositories, right? The code code softwares, right? So this is just basically tools used by the software developers to keep a track of the code coverage in their current projects, right? So attacker was able to insert, it was able to compromise like one of the repositories used by code code, right? And using that, right, it did gain access to like certain it compromised the developer's system, which was further led to an access of certain secrets, right, certain tokens, which led to further further damage and further for further focused and targeted attacks, right? So this is another example of software supply chain attack. There was another there was a recent research also done around it, right? So researchers found that there are almost 6.33% increase in cyber attack that aimed at open source repository, which is very correlating with the software supply chain attack, because in this also what attacker does is it tries to focus on this on all the third party components, obviously an open source repos, and find out an unpatched versions of it, and then uh, try to focus on exploiting that particular unpatched component, right? So there was another big org that was affected with software supply chain attack, that's in Amazon's Elastic Container Registry, right? So Amazon's ECR, it's a public gallery that helps users to that enables users to basically upload or pull and Docker based image to ease the development process, right? So there was this exploit which was carried out for this particular service that is managed by the Amazon. So it was identified that the resources of how the Amazon runs uh, certain of its own resources, that I am one of the service of Amazon, it's called as an IM, right? So IM roles and policies, it does requires access to drive ECR, right? So by default for any account it has read write access to ECRs, right? But obviously if you're configuring it, so it does requires an access to make an updation deletion API calls to it, right? In order to exploit this particular kind of an attack, right, you do require access to the temporary credentials of Amazon Cognitive, right? By finding a and so the attackers found a way to gain temp credential access of Amazon Cognitum, where it tried to compromise uh, the read and write access for Amazon ECR public gallery, right? And it was able to inject its malicious content in it, right? So this resulted into the further exploitation. So the malicious code, it like executed on the machine that uh, pulled and ran the image that was compromised, right? So whether it's like on the user's local machines, or it's like in the Kubernetes cluster or any cloud environments, right? So whoever is using that particular compromised machine, right, sorry, that compromised image was actually vulnerable to software one kind of an this cyber attack, right? So since it's an increasing percentage of this kind of an cyber attack, so it's a bit of an concerning for all organizations who are using, or who are still not aware of what kind of components that their softwares are using, or having a lack of visibility on those, right? So how one could perform a risk assessment, and how would one organization could manage uh, certain risks that are uh, prevail to this kind of a cyber attack, right? So first we need to identify those areas of the software supply chain that are vulnerable to the to interruption of the support flow. For example, if there is if 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 there is a software, right, in production or has been product or in the developing phase, right? So there should be like a proper visibility of what all processes have been defined, the distributions of it, right? All the libraries or components that particular software could use with the versions of it, right? So a software, we can say that a software is secured till then we have a proper visibility on all the third party component that it is using. So as long as the third party components, the versions are being used at the latest ones, right? So until then we can say that one that this particular software or product is like secure. But uh, uh, what if the used libraries or third party component has its own dependency on certain other packages that you as a developer or you as an like an entire team are having a lack of visibility on, right? So we need to get all those informations around it. So I've seen like a multiple organization of, instead of having an internal team of for software development, we do ask, I mean, or or make partners or make business with certain other vendors who does this kind of an software development for us, right? So in that case, right, when working with some other vendor for software development, right, so there is a possibility and lack of area where we do not have an entire visibility on what all distribution has been happening, right? Because sometimes it's not always what has been showed in the front page and the actual process that is being running behind, right? So identifying those key areas where this could be like an attack surface for an attacker, right, is the first thing to identify. Then the kind of a team that is being involved in this particular areas, right, to like have a responsibility to have an appropriate visibility on what all teams have been involved and what are the daily based activities that they would be doing, right? Having visibility on that, then assigning and streamline process so that there is no any uh, disruptions, right? And so the breakage, right, that could leave certain area into like and could be exposed, right? And then there are kinds of technology involved, right? Having like are we using a proper licensed version on it, or are we are all the dependencies met? Are we ensuring that the integrity is the checksum has been performed, and all those we have to cross verify, right? And the certain external events, right, that could occur. So it could be having it integrated with some other software, checking for the dependencies as well. Again, the integrity check should be like one of the key aspect to it, right? So these are the certain steps that one can take in the risk assessment and risk management process, right? So let's move on to the next slide. So I've just prepared a small demo on dependency confusing attack, right? Which is similar what we talked in our previous slide. So I'm just gonna show you a quick demo on it. So let me re-share my screen again. So I hope my screen is visible to you all. So I have created one package that's a simple Node.js project, and the code, it's a very simple code of hello world. It would just print hello world. So I've created this
Anja, can we
simple.
zoom it? Can we zoom it a bit?
Yeah, sure. So this is the small hello world. Uh, I'm sorry. So this is the small hello world. Uh, I've just created this for a demo. If you would see, so I've also created a few packages to it, and I've also added the dependencies in it. Uh, yeah. So this is the packages, and I've added a few dependencies in it. If you would, so I've added one express dependencies, another one is internal package, right? So and I've created this I've asked, I mean, I've made it like in I've added this malicious script, I've injected this malicious script into it, right? So whoever will install this particular package, I mean it does nothing, but I mean it causes no harm. So it would just, you know, print you that you have been hacked or some error note as specified. I mean it would just run this particular script, and it would just showcase you that you have been hacked, and it would just exit, right, if there are no errors. So what I've done is, so this is my small project for this, so I've just uploaded the same on npm, right? That's in package manager. So if you would see, so this is my internal package that I've created. I've added the three dependencies in it, right? Only one pull request. Okay. I've also added the Git repository to my project. So whoever will, you know, try and install this particular package, right, will end up installing my malicious package that I've created, right? So this is the basic idea in everything. So as we were talking about earlier about the dependency confusion thing, right? The typo spotting as well. So say for example, if this my internal package has like a real name, like any other that's very specific to one of organization's private repositories or private packages, right? So if this was replaced to the legitimate one, right? And if you would see, this npm keeps a track of all the versions, right? So the current version that I've uploaded was like couple of months ago. Yeah, it also shows last published like a month ago, right? So this is my current version. So say for example, if I just go and publish a new version of it. I'm so sorry. I've just got this error of npm. Okay. So okay, fine. So let's just walk around with what we have right now. So say for example that this is the latest version for this particular package, right? And if any developer or if any end user ends up installing like npm I installing my internal package, so it will end up installing the malicious code, the malicious package that I've created, right? So this is the whole idea around it. How the dependency confusion works. I've also written a blog around it, the dependency confusion attack, where I have a pretty good chart flow diagram for the users to understand that how the idea of software supply chain attack works. So let me just quickly scroll it through it. Yeah. So so whenever we type in npm I, so I is for install, and then we provide one package name, right? So that particular package and all the packages lists and its dependencies is covered in this package.json. So I've also showed you my package.json, and it contained like two dependencies, right? So I've kept two dependencies for this particular package that I have used in my project, right? So it does like check if the register value is set. So if the register value is set, so it will go and cross verify the value. So if the value matches, right, then it will use that particular set register value and install the package. But if it do not find the set value there, right? So it just basically I'm trying to give you an overview of what is public and private sources of installing the packages. Like also we earlier discussed that sometimes the package install also goes by the versions of it, right? And in case of an npm, it does have an checksum called as a register value set, right? So but obviously in my public repos in my public register I do not have this kind of a value set, but I do have like keeping a track of the version that I've maintained for that particular package, right? So the check goes like if the value is set, you would go and install it from the said repository. No, then look a public registry for the same, right? So in my case it would somewhat happen like if the value is not set, right, so it will go and look for the publicly available registry. So my internal package is a kind of a package that is publicly available, right? If anyone could just google this, right? So it would I mean this particular package would be displaying at their end as well. and all they need to do is just type in npm I and the package name, and you will end up installing the malicious one, right? So this is the idea of how the software supply chain attack actually works, right? So moving back, I just hope that this is clear. Even if not, then we're gonna have like an Q&A session at the end. So that was a small quick demo on dependency confusion attack, right? And what are the best practices to prevent this kind of an attack, right? So what an organization at its own level can do is it would definitely having their own private environment for installing the packages and everything is an uh, would be an ideal suggestion. But another one is also having like a cross verifying the checksum integrity of it, right? So whenever we install any kind of an package or any kind of an component, right? So there is an check called as an checksum integrity check, right? That will help to identify that is the integrity of this particular package is cross verified, verifying the source from which that particular package has been installed, especially when using a command line interface to install certain packages or install certain libraries or components, right? So maintaining that, also having a visibility on what all allowed packages. I mean, basically creating a list of all the allowed packages that could be like changing one, but there should be like list of allowed packages to be somewhere configured on an proxy level, right? So even if any user is trying to install certain library, right, whose integrity check might fail, or whose one of the other checksum um, mark could not happen, right? But since the proxy level verification checks are implemented, and I mean it's just more like, to put it in a simpler way, to just allowing to be installed certain repos from certain sources and blocking the rest. So say for example npm js is the kind of uh, package manager that I want to allow for my organization. So I will have an integrity check for it at my proxy end. So if there are certain packages that goes behind certain whitelisted sources or whitelisted repos, so it will throw developer an error saying that so and so is not in the list of an allowed components, right? So we could have that, right? Ensuring that the end-to-end security, I mean, even if there are by any chance the developer has made a typo mistake or fall for some phishing uh, you know scams, or was a victim for dependency kind of a confusion attack, and has some or the other ways uh, has installed a malicious package. So there should be like an end devices or ADR, right, and endpoint security devices that should promptly or proactively, block from that particular event from installing or from performing the kind of an activity that it is intended to do, right? This is the one thing. Another one is having an end-to-end visibility, right, on entire process or entire distribution for that particular software production, when it's in the developing phase, right, or in the intermediate stage, or in developed product, or entire product developed software, right? So having an end-to-end visibility on all the sources and all the components or all the list of distributive packages that that particular software is using, right, along with the versions of it, maintaining the tracks of each and everything in a some centered location. That is that is what quite is an important one for every organization to look for, right? Keeping like keeping a track of the new cves that keep on evolving and keep on being discovered by the security researchers, and ensuring that we have certain security checks installed and implemented at our end, right? I mean at every at every organization level is quite important. Having the operational security checks in place for all the resources that any organization is using, having and like in benchmarking type, even if it's for like uh, servers, maybe it's on premises or maybe it's on cloud, certain web application that is hosted on premises or on cloud, monitoring the entire attack surface for all the resources that a particular organization is using, having an end-to-end visibility on the internet facing applications, or on and also on intranet based applications, right? Having an like complete visibility on the security postures of all the resources that you're using is one critical aspect that every organization to look for. And also and like continuously and proactively monitoring the attack surface for your organizations, that is what having the complete visibility on it, right? So I think these are the best practices that one can follow to prevent itself from software supply chain attack. Also, speaking of which, this topic that quite occurred to me lately, very sorry for that. There's this project which was released by OAPS, that is dependency checker, right? So that's an amazing initiative that OAPS has taken. So 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 basically that scans your entire repositories, right? That where your centralized development happens, right? And it checks for the versions and the component that the particular web application is using. And if it's and if it's using the vulnerable or unpatched version of the components, right? So then the tool highlights it's to you, right? So having an attack surface monitoring tool in place that will proactively keeps on looking for all the uh, all the components or all the list of third party libraries or packages that you use, along with the version, with the latest I mean, whether you're using the latest version or not, or whether it's in some dependency that has an unpatched version still in use, right? So dependency tracker, right? That was an amazing initiative that was taken up by OAPS, which does gives you like pretty much clear visibility on the list of the third party component that you're using, along with the version specifics of it. So if you're using any unpatched version, so it would give you like an alert kind of a thing, right? So and since this area is evolving, so there are a couple of other attack surface monitoring tool as well that are emerging in the market. So maybe you could use one of anyone that does gives you like I mean, which is the best feasible for your kind of in development that you guys, that one organization follows, right? So attack surface monitoring is what one should keep in daily practice, and having an entire visibility on all the types of component that we use, right? So that's the best practices for to follow to prevent from this kind of a cyber attack. So if you have any questions, so I'm open for questions.
Hi, Andhra. I don't see any questions at the moment.
Sure.
Thank
Okay.
you so much for sharing wonderful insights. It was really good.
Thank you so much. Thank you.
Yeah, I am sure people will reach out to you and we will share your contact details in the chat option so that they can get back to you. But thank you for
Sure.
sharing the wonderful insights, especially on the attack surface and how we can remove that. It was wonderful.
Sure. Thank you so much for this opportunity. It was lovely being here, and it was really a great experience. And I would love to come up with certain more topics as well, and share it with the amazing people that we have here. Thank you.
Absolutely, absolutely. Thank you so much, Antara, for joining us, and thank you so much, everyone, for listening to us. Take care.
Thank you. Take care.